Hi guys, if in the previous examples I had to find the function, I had to use modeling to find the function. This one in this video we have several examples where the function is given and they ask questions about this, right? So this is much easier in my opinion. Um, as a wave passes jetty pylon, the depth of the water d in meters at time t seconds is given by the function. Okay. Well, this might not seem a very useful example for like, okay, what's the purpose of this? Let's think about energy generation. When we need to generate energy, for example, waves can be a way we can make electricity out of. So imagine the study of waves can actually give us a lot of clean energy in the future that now we extract from oil, from petroleum, right? So it is the future. The study of how we get energy from the wind, from the waves, and all this for clean energy. Okay, so now we have to focus on this function, which is 0.2 sine of 50t plus 5, and the first question is find the maximum and minimum depth of the water. When do this occur? So let's see. So we have d equals 0.2. This is the amplitude, right? Sine of 50. This is related to the period plus 5 when t it's bigger than 0. Okay. Okay, so let's think about this. Let's graph this function. Let's graph this function. And let's think about it. So this is starting at 5, and this. So all this sine has been moved, shift up 5 times, right? And then we have a sine, correct? And the amplitude is 0.2. So that means that the maximum value is going to happen if we add 5 plus 0.2. That's going to be, so it's 5.2. So maximum, just thinking, you see, you don't have to do math, just think. Maximum is 5.2, while the minimum is going to be 5 minus 0.2, which is 4.8. Correct? That's the minimum. Now, when did this occur? Okay, that's interesting, very interesting. So let's do some math in here. We will need, we'll need paper here. So to know when this occurs, we can do several things here. I'm gonna go for one thing. I'm not sure it's gonna be the easier one, but it's it's an option. So here, this value is the value of the depth of the water, right? 5.2 and 4.8. So it's d. This is d. If we want to know at what t this happens, we can just put this 5.2 where the d is. Just solve for t. Let's try it. So we substitute 5.2, put in here, so we have 5.2 equals 0.2 sine of 50t plus 5, right? How do we solve this equation? So subtract 5 both sides, correct? So we can have 0.2 equals 0.2 sine of 50t. Next step is divide over 0.2. We're trying to solve for t, right? So when we divide this, it's going to be 1 sine of 50t. Okay. So, and now What's the next step? The next step is the inverse of sine, arc sine both sides. So we're gonna have arc sine of 1 equals 50t. How much is the arc sine of 1? Well, we must think that this is in radians. If nothing is set, always radians. So if we think about, we don't even have to use the calculator. Let's think. So the sine, it's 1 at pi over 2, right? This is pi. This is 2 pi. So the sine, it's at its highest value at pi over 2. You can also use a calculator if you wish. So that would be pi over 2. So I have pi over 2. But it repeats every 2 pi, right? Plus 2 pi times n equals 50t. The last thing we have to do is divide over 50, right? So we have t equals pi over 2 times 50. That's how we divide, plus 2 pi n over 50. So that's pi over 100 plus pi over 25 times n, right? So this is the solution for t. So this is going to happen for every t. If we do the math here, so pi, so pi over 100, 0.31. 0.31 in seconds. These are seconds, as the problem says seconds. So this is 0.314, and this is going to repeat every pi over 25, which is plus every 0.125 times n, where n is 0, 1, 2, 3, because we have a domain restriction. It says only for t greater than 1, so that's it. So every 0.125, this is going to repeat and repeat and repeat and repeat. Okay? So here we go. So we would do the same thing for, this will be the maximums. We're going to have this, this is going to be the maximums, these seconds, so maximums. So again, we're going to have 0.3, so we have, if we look at the maximums, we have the first one at 0.314, and then plus okay, 0.314. The next one is at 0.439. Then these are seconds, plus 0.125. The next one is at 0.54, and like this, right? So we're gonna have maximums every 0.125. So the same thing can be done for minimums. Okay. And then B says find the first time the depth of water reaches a mark on the pylon which is exactly 5 meters above the seabed. Okay, so here they're changing what they're asking. Before on A they give us the depth, right? And oh no, it's the same. The first time they're asking time again. So the same thing. So, but now they're asking 5 meters, right? So, well, but this is pretty obvious, isn't it? That's gonna happen at 0. Find the first time the depth of water reaches a mark on the pylon, which is exactly 5 meters. Well, that is because this is a sine function. That's going to be at t equals 0, right? But we can still solve it. So it's 5, 0.2 sine of 50t plus 5, right? We subtract 5 both sides. 0.0.2 sine of 50t, and then we divide over 0.2. That's going to be 0 sine of 50t. So if we will do the arc sine, we're going to have arc sine of 0 equals 50t. This is going to be 0. Because I know it in here, I just consider just looking at the graph, right? So that's gonna be 50t equals 0. So the first time is gonna be at 0, right? Okay. Well, this one is pretty obvious, right? Find number 2 for the function. This is the function -3 cosine of 2x plus 1.2. So how are we gonna find the amplitude? The amplitude is always the value we have here. That's gonna be 3. It's in absolute value. So even if it's negative, we just put it positive. Period. So this is gonna be in degrees because we see it in here, right? So if this is in degrees, then that means that the period is b equals 360 over t, right? If we solve for t, because now this is b, right? It's a, b, this is d. C is not present here, okay? So if we solve for t, we can just multiply t both sides and then divide b both sides. If you do this, right, it's going to be tb equals 360. Then we divide over b both sides, and we're going to have t equals 360 over b. Okay, so then because b is 2, then we have 360 over 2, which is 180, right? So 180. So we don't have to put the degrees here. We don't need to. So t it's 180. T it's 180. The period. The minimum value. What's the minimum value? Again, this is going to be a -3. So that means that if this is 0, -3 will be here. This is where we place the axis, and then it's. I'm sorry. This is the shift, the vertical shift. So it's positive 1.2. So I have to do it again. So it's gonna be 1.2 positive, and then -3. There's a cosine -3, so that means that it will start here and it will go like this. It's a cosine that has been flipped. So it's gonna start here at negative. This is going to be -3, but because it touched 1.2, 1.2 minus 3, it's -1.8. Am I right? Okay, so this is going to be, the minimum value is -1.8. Find the values of x for which of x equals 0. Okay, 1 is 0. So again, we have to solve here. We have to solve here the equation, right? Now they're telling us that the value of f of x, the value of f of x is 0. So we write the function f of x equals -3 cosine. As you can see, it's all the time the same thing. Just keep asking the same things. So now they're telling us that this is 0, right? So this is 0, and then they're asking us to find x between this restricted domain from 180 to 360. So -3 cosine of 2x plus 1.2. Okay. Now, if we subtract, first thing we're gonna do is just gonna subtract -1. subtract 1.2 both sides. So we're going to have negative 1.2 equals negative 3 cosine of 2x. Now we're going to divide over 3 both sides. Negative 3, sorry. Divide over negative 3 both sides. And then we're going to have negative 1.2 over negative 3 equal cosine of 2x, right? Then the negatives, we cancel the negatives. So we're going to have 1.2 over 3. We're going to do this with a calculator. 1.2 over 3. And it's 0.4. 0.4 equal cosine of 2x, right? Then we have to make the arc cosine. So the inverse cosine both sides. We're going to have arc cosine of 0.4 equals 2x, right? Then so we have to do this with the calculator. Let's make sure the mode is in degrees. It is in degrees. So now we're gonna do arc cosine of 0.4. So it's 66. 66. So this is gonna be 66. Okay. 0.42 degrees. And then remember that when we do when we solve for cosines, and remember the unit circle, we're gonna have the same solution but negative. So this is gonna be the positive solution, and then negative 66.42 is gonna be so the positive and the negative solution. Okay, and this is gonna keep repeating every 360. So we have two solutions here, right? So we have one solution, it's going to be 66. You know what? I'm going to avoid the 0.42 to make it easier. Plus 360 times n. And then the other one is going to be negative 66. 0.42. No, we said we're going to avoid it. Plus 360 times n, right? So now if we keep, and this is going to be equal to 2x. So that means that when we solve each one of the equations, this is going to be, we divide over 2 both sides, this is going to be 33 plus 180 times n equals x. And for this one, it's going to be negative 33 plus 180 times n, correct? And now let's keep adding 180 because we have to find the solutions between 180 and 360. So let's see how many solutions we have in that range. So we have 33 plus 180, that's going to be 213, which is in the range. So one solution I get from here is 213. If I add 180, that's going to be too far. It's going to be above 360. While this one, negative 33 plus 180, that's not going to be enough. But if I add 180 again, I get 327, which is also a solution inside of this domain, this domain, okay? So now, let's think about it. Let's check. If I do cosine of 213, no, sorry. What I'm doing wrong here. No, it's 2x, right? And I should get 0.4. So if it's 2x. So that means if I do cosine of 2 times 213, I get close to 0.4. It's not exact because I have dropped that point 0.42. Okay, and if we do cosine of 2 times 327, oh my god, missing the times 237. Wait, I did something wrong in here. Oh my god, it's 327. Cosine of 2 times 327. Here we go, 0.4. Okay, so that's it. I think it's enough. The next one is exactly the same one as the top, so I think you can solve it easily. Okay, have a nice day, guys.